Hello students, and welcome to your own channel Be Methaholic. Now here I have come with chapter 2, types of relations, and we are going to study about the different types of relations. I begin with empty relation, universal relation, identity relation and equivalence relation. So let's see what these type of relations are all about along with the examples. So we begin with the empty relation now. As you can see, empty relation or void relation, as you can see in the set theory, we have defined the empty set with empty or void or null. The same here, empty relation or void relation. A relation R in a set A is called an empty relation if no element of A is related to any element of A, and we denote such a relation by phi. Okay, so what have you understood from this? That if no element of A is related to any element of A, means suppose if I take the example here, then you will understand it very easily by example. Suppose I take any set with the elements 2, 3 and 4, and suppose I define the relation R as all the elements of x and y such that x plus y is equal to say suppose 25, right? Now as you can see, the elements of set A are this, and the relation defined is x plus y equals to 25. Now if I am going to put the values of A as 2, 3 and 4, we will see that here no element would satisfy, that the sum should come out to be 25. Hence the relation defined will be coming out to be a null set. So such type of relation is a empty relation. Another example we can take, example 2 we can take, that suppose if I say that set A defines number of boys, or you can say set A you can say is defining the number of boys, okay, and of course set relation defined is number of boys in a school. हम इसको ऐसे ले सकते हैं that set A is defining the number of boys in a school, or that may be a boys school, and the relation defined here is AB such that A is a sister of B. A is a sister of B. Now as you know, if we take the number of boys in the school, all are boys, so this type of relation where it is defined as A is a sister of B will not be justified in this case. So the relation defined will be an empty relation or a phi, right? I hope you have got this. Next move to the let's move to the next type of relation here, universal relation. Now as you can see, a relation R in a set A is called a universal relation. Now you must have understood by the term universal. Universal means it is accepted by everywhere, it is accepted everywhere, it can be defined everywhere. So if each element of A is related to every element of A, so whatever the set A comprises of, it should be defined for every element of set A. So what should be the answer in this case? So let's take the example here. Suppose set A defined here is, I may take it anything, suppose you take, I am taking it 1, 2, 3, 4, any elements you can take here, and here the relation defined is AB such that A plus B is greater than 0, right? The sum of the elements present in set A should be greater than 0. Now as you can see, these are the elements, and if we are going to add these elements, this will definitely be defining it to be greater than 0. So this such type of relation is considered as universal relation, right? It's clear to everyone. Let's move to the next type of relation here now. Let's come to identity relation. Now a relation R in a set A is called identity relation. Now this identity relation is defined as A belongs to A. Now such type of relation where the same element should come. Identity stands for identical elements, okay? So identity word means identical, I repeat. So what should be the identical condition for this, or what should be the criteria for the relation to be an identical relation? So here let's see with the example. If I take A as ABC, right? So the relation, identity relation, you will have the elements in this set will be AA, BB and C comma C. Now such type of relation is known as identity relation. Similarly, you can have it as set B. Suppose I take it as 2, 5, 7. Then the identity relation will be like this: 2, 2. Then we have 5, 5 and 7, 7. So such type of relation will be called as an identity relation. Okay. Now let's see the different last, which is known as the equivalence relation. Now there is a condition for equivalence relation. Please see this, whatever it is written here, it will be explained through a proper example, and the easy example I am going to take so that you can understand it very easily. आप बहुत अच्छे से समझ सकते हैं अगर हम इसको बहुत इजी तरीके से समझें तो. सो व्हाट टाइप ऑफ रिलेशन इज कंसिडर्ड एज एन इक्विवेलेंस रिलेशन? एन इक्विवेलेंस रिलेशन इज दैट रिलेशन विच सेटिस्फाइज ऑल द 3 कंडीशन, दैट इज रिफ्लेक्सिव, सिमेट्रिक एंड transitive. If all the 3 relations are satisfied, then we can say that the relation is considered as an equivalence relation. Okay. Now what is the first case defined here? What is reflexive relation? Reflexive relation is that relation in which if AA belongs to R, means the same element is belonging to R, the relation defined for this, for all A belongs to set A, then it is considered as reflexive. What is symmetric relation? Symmetric relation is called a symmetric if a relation in R, if AB belongs to R and BA belongs to R, then in fact it should come at implies if AB belongs to R, implies BA should also belongs to R for all AB belongs to A. Then we come to transitive relation. Transitive relation says a relation R in a set A is called transitive relation if AB belongs to R and BC belongs to R, implies AC should also belongs to R for all ABC belongs to set A. So if all the 3 conditions are satisfied, we can say that the relation is considered as an equivalence relation. Now let us understand it with an easy example here. Now suppose I'm taking the example, there are 2 parallel examples we'll take. One is defining it, another is not defining it. So the easiest example will be, let T defines the set of all triangles. Here I am defining T as a set of all triangles, right? And the relation defined here is T1, T2 such that T1 is congruent to T2, right? T1 is congruent to T2. Now let's first check the reflexivity of this, that is whether the relation is reflexive or not. Now we know for reflexivity we should have this, that T1, T1 should be satisfied and T1, T1 should belongs to R. Okay. Now what is this? The first case says T1 is congruent to T2. Okay. Now as you know, every triangle is congruent to itself. We all know that every triangle is congruent to itself. Hence this condition reflexivity is satisfied. Okay. So T1 comma T1 belongs to the given relation. Second case is symmetric. Means what we have to prove in this, that if let T1, T2 be 2 triangles here, then if T1 is congruent to, if T1, T2 belongs to the relation, implies T2, T1 should also belongs to the given relation for all T1, T2 belongs to the set A, right? Now what does this mean? This means that if T1 is congruent to T2, now all of you know that once in given triangles, if T1 is congruent to T2, obviously T2 will be congruent to T1. Both the triangles will be congruent to each other. We can say this. Hence the condition of symmetric gets satisfied. So every comparison of congruency will be can be done, that if we take 2 triangles, then both the triangles are congruent to each other. So symmetric condition gets satisfied. What is the third case in this? It is transitivity. That is transitive relation. Now how will you prove this transitive relation? This says let T1, T2, T3, let T3 be another triangle in this. If T1, T2 belongs to the relation and T2, T3 belongs to the relation, then, or you can say implies, T1, T3 should also belongs to the given relation, right? That means if three triangles are there, that is T1, T2 and T3, then if first is congruent to second and second is congruent to third, then definitely first will be congruent to third. So all the three triangles, if we are comparing, then if the comparison says that all the three will be congruent to each other. Hence, we can say that the set of triangles is an equivalence relation. Simple example, you can understand it easily. Set of triangles is an equivalence relation. Now, why is this an equivalence relation? Because it is satisfying all the three conditions here. If children remember, if any one of the three conditions is not satisfied for any of the case here, then we are not supposed to consider it to be an equivalence relation. For a relation to be an equivalence relation, all the three conditions should be compulsorily satisfied in this, right? Now let's take another example which is saying it is not satisfying the condition. So the next example would be, again let us take it as, let T again be a set of triangles. In fact, in this I am going to take, let L1 denotes, let me erase this part here. Now let L1 denotes, let L denotes rather set of lines. Now I am going to take the set of lines, okay, and here the relation defined here will be, if I consider two lines to be L1 and L2, then the relation defined here will be L1 is perpendicular to L2. L1 is perpendicular to L2, right? Now let's see what does the three conditions says in this. Let's talk about reflexivity or reflexive condition. Reflexive condition says that, you know, the reflexive condition says that L1 and L1. Now what does this L1, L1? It should belongs to R. Now the relation is that L1 is perpendicular to L2. Now L1, L1 belongs to R. This means that every line cannot be perpendicular to itself. Remember that every line cannot be said to be perpendicular to itself. Cannot be perpendicular to itself. So the condition of reflexive gets omitted in this, or you can say the condition of reflexive does not hold in this case. Second is, you can take it like this, it's symmetric. Symmetric case क्या कहता है? That L1, L2, if it is belonging to the relation, it implies that L2 and L1 should also belong to the relation, okay? Now as you can see, if I draw two lines, if I take two lines here, this is L1 and this is L2, then we can say if L1 is perpendicular to L2, then definitely L2 is also perpendicular to L1, vice versa. Both the things can be said, both the lines are perpendicular to each other. So we can say that the condition of symmetric holds in this case, that here this condition is satisfied. Now let's come to the third case, which is known as transitive. Okay, now what is this case? It says that if I take third line, L3 be another line, then L1, L2, if it is belonging to the relation, and L2, L3 belongs to R, then L1, L3 should also belongs to the relation R. Now as you all know, if suppose I take L3 another line, if this is line L1, this is line L2 and this is line L3, right? Now you all must be knowing that if first line L1 is perpendicular to L2, then and if L2 is perpendicular to L3, then L1 cannot be perpendicular to L3. The condition here says that if two lines are perpendicular to the same line, then both the lines are considered as parallel lines. They cannot be considered as perpendicular to each other, right? So therefore the transitive relation does not hold for this criteria, that the relation is not satisfied. So reflexive, it is not reflexive, neither it is transitive. It only satisfies the symmetric condition here. So we can say that the relation L1 is perpendicular to L2 is not an equivalence relation. I hope you have understood. This was a very small video I have made on the types of relations. So I hope the concept is clear about the types of relation to every one of you. Soon we'll meet in my next video. So goodbye for now. Happy learning, easy learning. Bye.